This is coaxial cable. It carries the Golf Channel, the Internet, Netflix, and telephone calls to and from your home. It's mounted on poles or buried in your yard. There are nearly 2 million miles in North America. This is what's inside the aluminum shield, polyethylene foam, surrounding a copper-clad aluminum center conductor. It was never meant to be outside the shield. But now that it is, a fiber optic cable can be installed in the shield to dramatically increase internet speed to your home or business. So how did it get outside the shield? Deep Fiber Solutions ejects that foam core with the center conductor and replaces it with a microfiber cable to extend fiber optics for greater speed and capacity deeper in a cable operator's network. We do this dramatically faster and at significantly lower cost than conventional construction techniques and without disturbing customers. This is how our turnkey process works. The first thing our Deep Fiber Solutions team does is determine if there are buried splices or faults in the cable. They use a TDR to locate these. If they find a splice or fault, they coordinate with a construction firm to pothole the location. This small hole then becomes a fluid injection or core ejection point. When coring is completed, the two ends of the cable at the potholed location will be sleeved for seamless fiber installation later. In addition to an occasional buried splice, all pedestals are used as fluid injection or core ejection points. In the past 35 years, cable operators have upgraded their networks several times, from 35 video channels in the early 80s to today's digital offerings with hundreds of video channels, the Internet, telephone service, and now home security, all delivered through new, larger cables. Consequently, Deep Fiber Solutions can often rely on an inactive or abandoned cable to be available for coring and installing fiber. Where an inactive cable is not present, Deep Fiber Solutions switches service to an alternate above-ground temporary fiber, or coax cable, until coring is completed and the permanent fiber is installed that day. These changes to the alternate above-ground cable and back to the permanent fiber cable normally take less than 60 seconds. The Deep Fiber Solutions team actively manages service delivery using rubber bumpers, for example, on roadways to protect the alternate service. The temporary cable is only needed for the day of the installation work and is removed after the coring, fiber jetting, splicing, and cutover is completed that afternoon. Using special connectors and an engineered biodegradable pressurized fluid, Deep Fiber Solutions technicians channel the fluid between the foam and the shield. This patented process causes the foam to compress and break away from the shield, which makes it possible to eject the foam from the cable. Let's take a closer look. It takes just minutes to prep the cable and attach the injection side connectors to the cable. But proper prep work is important because the fluid must be directed to the outside of the foam to compress it to about 95% of its initial size. Meanwhile, another technician is using the computer aboard the truck to select the cable type, size, and length of the span to be cored. These selections then automatically calculate the proper amount of fluid to be injected. The same computer precisely controls the ideal fluid pressure for each cable type, size, and span length. At the ejection end of the span, the technician installs a connector with a gate valve and pressure indicator. As pressure builds in the cable, the technician can see when the fluid begins to arrive. At the injection end, a technician uses an electronic dispenser to track the fluid pressure and how much fluid is being pumped into the cable. When fluid appears in the bleed tube, that signals the arrival of the fluid at the ejection end. Then, it's a simple matter of opening the gate valve to allow the core to be ejected. This happens quickly. The electronic dispenser is programmed to automatically shut off when the required amount of fluid has been dispensed and before the polyethylene completely exits the sheath. The last few remaining feet of core is simply pulled out by hand. It took Deep Fiber Solutions less than 15 minutes to core this 600-foot span of cable. This is a fraction of the time it would have taken to permit and bore or trench the same span. It also avoids the potential to hit gas, water, and telephone lines, irrigation systems, and drop cables. And we're easy on landscaping too. Now that the core has been ejected, the team cleans the shield of remaining fluid using air pressure to propel a sponge-like plug through the span. The fluid is captured in a simple bucket and returned to a tank on the truck containing recycled fluid. We will use it again and again on additional spans. The Deep Fiber Solutions team repeats the coring process for additional spans of cable between pedestals or vaults on the way to the target location, where perhaps a new node will be installed. When all spans have been cored, the team installs a slack loop tube at pedestals or vaults to join the spans together. This makes it possible to jet a microfiber cable for up to 4,000 feet without a splice. The shield is now ready to be used as a conduit for microfiber cable installation. A 200 psi air compressor is integrated in the Deep Fiber Solutions mobile factory, the truck, to eliminate the need for a separate tow-behind gas-powered air compressor. In addition to providing the air pressure to help purge fluid from the shield, it powers the fiber blower, which can install fiber at a rate of 250 feet per minute. Riding on a cushion of air, the microfiber cable literally floats through the aluminum shield, slack loop tubes around corners, and even through expansion loops in aerial cable. It takes less than 3 minutes to install the microfiber cable in our 600-foot span. The technician then quickly removes the slack loop tube and either splices fibers needed to serve homes from this vault or pedestal, or coils the fiber slack for future use. Microcore fiber cables are manufactured with ribbing, which allows air to blow the cable through shields as small as a ½ inch in diameter. These pencil-thin cables are produced with 12 to 192 fibers. Microfiber cable can also be manufactured as a hybrid with copper conductors for network powering of active devices including micronodes, line extenders, or amplifiers. These conductors simply take the place of buffer tubes. With copper conductors for network power in the microfiber cable, an operator can install micronodes in pedestals to cost-effectively achieve a fiber-to-the-curb architecture where common coax drop taps were once installed. The technician ring cuts the fiber cable at the pedestal and only splices the 2 fibers needed to serve the 2 homes from that micronode. The drops can be upgraded to fiber later on the operator's schedule or when a new higher-speed fiber-based service is sold. Deep Fiber Solutions is the low-cost alternative in virtually any setting where coax is available to be used as a conduit for fiber installation. Examples include node splits, converting nearby coax to fiber for cell sites or commercial buildings to generate new revenue, to solve for wind loading problems in aerial applications, or as a substitute for time-consuming and costly boring and trenching, especially in fiber-to-the-curb or fiber-to-the-home applications. Here at Deep Fiber Solutions, we're all about the green initiative and recycling. We recycle the polyethylene foam core and center conductor and the biodegradable fluid. And when you think about it, we even cause the recycling of an operator's most valuable asset, the existing legacy coax network. It was costly to install years ago, but by using Deep Fiber Solutions technology, the aluminum shield is now used as a low-cost conduit for an advanced high-capacity network without impacting customer lawns and landscaping. We're green. For more information about our proven, low-cost method of converting coax networks to fiber optics, visit us at deepfibersolutions.com.